right, today we're going to start where we left off yesterday, talking about coterminal angles. So yesterday we did everything in terms of, we figured out what quadrant angles we're in, reference angles, positive and negative coterminal angles. But today we're going to talk about a different way to measure angles. So angles can be measured two different ways. Usually we use degrees, okay? But there's another form called a radian. And all we need to know right now is that 2 pi radians, so 2 pi is a measure in radians, is equivalent to 360 degrees. Okay, so I'm going to basically go about the same way, or the problems the same way I did yesterday. However, today we're going to look at angles in terms of radians. We're going to have lots of fractions today, but we'll work with them and try to make them as easy as possible. All right, so yesterday we talked about quadrants. We talked about reference angles. Remember, it's how far it is to the closest x-axis. And then we talked about how to find positive and negative coterminal angles. Well, yesterday we added 360 degrees or subtracted 360 degrees to find those coterminal angles. Well, today we're going to do the same thing, except for we're going to be in radians. So we're going to add or subtract multiples of 2 pi. So 2 pi and 360 are equivalent to each other. So we're going to do the exact same thing. We're just going to measure in terms of radians. And our magic number for that is adding and subtracting a full circle, which is 2 pi. All right, so we're going to start with the first example, number 12, 5 pi over 11. So the first thing I want to do is I want to label our x and y axis based off of what we just talked about. So before we would go 0 and 360. Well, we don't want to use 360 this time, but we said 360 is the equivalent of 2 pi. So one full circle around is 2 pi. Okay, so that means a half circle has to be pi. Okay, and then if I cut pi in half, that's pi cut in half. Okay, and then if I go three quadrants away, so if this is pi over 2, this is 2 pi over 2, which is the same as pi. So this guy down here would be 3 pi over 2. Well, we have a small problem because this problem isn't in terms of fractions with a denominator of 2. It's in terms of a fraction with a denominator of 11. Okay, so what we want to do is we want to fix these angles over here, the top one and the one on the bottom, and we're going to fix the one on the left in a second. And we want those to be in terms of 11ths. Well, we know this is the equivalent of 1 pi, okay? And I can make 1 pi a fraction with a denominator of 11. Okay, so 1 pi would be 11 elevenths, right? 1 is equal to 11 elevenths. And then 2 pi over here we want to fix. And again, we want to make it in terms of elevenths. Well, if 1 pi is 11 elevenths, 2 pi would be 22 elevenths pi, or 22 pi over 11. All right, so this one's a little bit trickier because we have an odd number here. So if I wanted a half a pi, I'm going to take 11, cut it in half, and I'm going to use a decimal, so I get 5.5 pi over 11. Okay, so again, the same idea we did here. So this is 5.5 plus another 5.5, which is 11, plus a third 5.5, which gives me 16.5. 16.5 pi over 11. Okay, now, one quick, easy way to figure that out is if I add 1, 2, 3, that's 1.5 pi. All the way going around. So I take 1 pi up here and I add the 5. 11 plus 5.5 gives us that 16.5, and that'll work every single time. So if we just add these two guys together, that'll give us our 1.5 pi down below. Okay, so now that we've written this circle in terms of 11ths, it's basically what we were doing yesterday. Where would 5 pi over 11 be? Well, this is 0 elevenths, right, or just 0. And up here is 5.5. So that means 5 has to be somewhere in quadrant 1. So this would be 5 pi over 11. Okay, so we know we're in quadrant 1. Okay, now if we talk about our reference angle, the only difference is we're not using degrees now. How far is it from 0 to 5 pi over 11? Well, our reference angle is just 5 pi over 11. Okay, and then let's take that 5 pi over 11, and we're going to add a full circle. Well, we said a full circle is 2 pi, but I want to add that in terms of 22 over 11, right? 22 divided by 11 is 2 pi. Okay, so if I add those together, that gives me 27 pi over 11, and there's my positive coterminal angle. Now, to do negative negative coterminal angle, we're going to do the same thing, but instead of adding, we're going to subtract. So I'm going to take 5 pi over 11. I'm going to subtract 2 pi, and in this case, 2 is the same as 22 over 11. So 5 minus 22 is negative 17 pi over 11. Okay, so the fractions sometimes get messy. However, we're going to work with them in terms of their denominator. So if it's 11ths, we're going to make our picture in terms of 11ths. This one is in sixths, so we're going to make our picture in terms of sixths. Okay, so the first thing we're going to do is our picture here. So I start at 0. All right, I know half a circle is pi, but since my denominator is 6, I want to make that 6 over 6, right? 6 over 6 is the same as 1 pi. So that means 2 pi in terms of 6. 6 and 6 would give me 12 pi over 6, or 12 over 6 pi, right? This fraction right here reduces to 2, and then we throw a pi in there. Now, since this number is even, it makes the half a little bit easier. So if I cut 6 in half, that gives me 3 pi over 6. And remember, if this is 3 plus another 3 is 6 plus another 3, this guy down here is 9 pi over 6. Okay, or like I mentioned up above, we can just take a half plus a 1, and that gives me the 1.5. So now our picture is in terms of sixths. All right, just like we did yesterday, I don't like the fact that this angle is negative. So what I'm going to do is I'm going to add, instead of 360, I'm going to add 2 pi. So I'm going to add 12 pi over 6 to it, which gives me a positive coterminal angle. Okay, now I can go ahead and use that over here as my positive coterminal angle, but more importantly, that's going to put that picture on our graph. So if I start at 0, I go up to 3, I go over to 6, I go over to 9. So 11 pi over 6 has to be somewhere here in quadrant 4. So it's in quadrant 4. And then just like we did with our reference angles, how far is that from 12 pi over 6? Well, from 11 pi over 6 to 12 pi over 6 is just 1 pi over 6. So I can either put the 1 in front, or I can just call it pi over 6, because that implies that there is a 1 in front. All right, so we already found our positive coterminal angle. And remember, we did that just by adding 2 pi, right, or adding 12 sixths. So in order to find our negative coterminal angle, we want to take negative pi over 6, because that was our starting angle. And this time we want to subtract 2 pi, but remember, instead of 2 pi, we want to subtract 12 pi over 6. So that gives me a negative coterminal angle of negative 13 pi over 6. So again, to find the positive coterminal angle, we took negative pi over 6 and we added 12. We did that way back in the beginning. So since it turned it into a positive number, we can go ahead and use that as our positive coterminal angle. All right, let's take a look at another one here. So this one was nice. It's sixths again. So we can actually use the exact same picture from up above. So I know that this is pi right here. And since my denominator is 6, I want to call that 6 sixths. We've got 0 over here and also 2 pi, but in terms of 6, 6 plus 6 is 12. So we just double the 1 pi over here. Up above, out of 6, I want half of it, so that's 3 pi over 6. And then add those two together, I get 9 pi over 6. So again, it's 3, 6, 9, or I can say, hey, this half was 3, a whole was 6, so 1.5 has to be 9 pi over 6. All right, so if I were to go around the circle, I want that circle to be between, or I want that angle to be between 0 and 12, 6. Well, this guy's a little bit too big. So there's a couple different ways to do it. I like to make it fit on our circle, so I'm going to take that magic number of 12, 6, and I'm going to subtract that. Okay, so that gives me 1 pi over 6. All right, so where is 1 pi over 6? Well, this guy right here is 0, and this up here is 3. So that means 1 pi over 6 has to be somewhere in quadrant 1. Oops, I don't know why I drew a triangle there. 1 pi over 6 has to be in quadrant 1. All right, so that makes finding our reference angle not so bad. From 0 to pi over 6 is just pi over 6. So our reference angle is pi over 6, which happened to be the same as the last one, even though it was in quadrant 4. All right, so to find a positive coterminal angle, we can take 13 pi over 6, and I can add 2 pi, which is 12 pi over 6, which gives me 25 pi over 6 as a possible coterminal angle. Now, realistically, we also found a positive angle when we subtracted 12 pi over 6. So that could also go in the same spot as the 25. All right, so this time, though, when I want to find a negative angle, I take 13 pi over 6, and if I subtract 2 pi, that gives me positive 1. So I've got a problem there because it's not negative yet. So what I want to do is I want to subtract 12 pi over 6 again. So 1 pi over 6 minus 12 pi over 6 gives me negative 11 pi over 6. So that would be one example of a negative coterminal angle. I could subtract another 12 and get negative 23 pi over 6 either way. So it's not really hard fractions. We just want to make this XY chart or the XY axis in terms of whatever denominator that we're given. All right, so this time we are given a 3 on the bottom. So again, all the way over here, I got 0 to start. I got 1 pi over here, but I want to call it 3/3. And I want to call this one 6/3, right? Because 3 plus 3 gives me 6, so 2 pi would be 6/3. Now, unfortunately, 3 is not even, so I'm going to cut 3 in half. That gives me 1.5 up top, so that's a half a pi, right? 1.5 divided by 3 is the same as half. And then if I take the top and the bottom and add them together, or if I go 1.5, 1.5, and 1.5, that gives me a value down below of 4.5 pi over 3. All right, so if I were to look for 14 pi over 3, the highest I go around is 6. Now, technically, I could go around and go 12 and then go 2 pi over 3 more. But what you're going to see what we'll do is when I subtract 2 pi here, that gives me 8 pi over 3. And when I subtract another 2 pi, which is 6 over 3, that ends up giving me 2 pi over 3. So basically what's happening is this is going around the circle more than once. I'm going to go around 6, I'm going to go around 12, and I'm going to go 2 more to get to 14. Okay, so we got to be careful here because straight up above is 1.5. I need to go 2. So that means I need to go into quadrant 3. So that would be 2 pi over 3. That's how far I had to go. Okay, so I'm in quadrant 2. Okay, and this time I want to find my reference angle. Well, this time my reference angle is over on the left side. So how far is 2 pi over 3 from 3 pi over 3? Well, that's just 1 pi over 3. Okay, so my reference angle is just pi over 3. All right, so now we find our positive and our negative coterminal angles. So I can take that 14 pi over 3 and I can subtract 6 pi over 3. Well, that gives me 8 pi over 3. So there's one example of a positive. Okay, I also could take that 14 pi over 3 and I can add 6 pi over 3, which gives me 20 pi over 3. Either of those are examples of positive coterminal angles because of the fact that the angles end up being positive. So even though I subtracted here, that still gives me a positive angle. Okay, so I can use that one or I could use 20 pi over 3. It does not matter. Okay, if I'm trying to find a negative coterminal angle, if I use 14 pi over 3, if I subtract 6 pi over 3, that gives me 8 pi over 3. Well, there's a problem because that one's not negative. So now if I subtract another 2 pi, I get 2 pi over 3. So I could add that one over here as another possible positive coterminal angle. But I still have a problem because I'm still not negative yet. So now I got to subtract another 6 pi over 3, which finally gives me a negative angle or a negative coterminal angle of negative 4 pi over 3. So you're going to continue to add and subtract multiples of 2 pi. So add 2 pi, add another 2 pi, or subtract another 2 pi, depending upon how big that angle or how small that angle is. All right, I want to squeeze one more in here. So I'm just going to kind of draw a little line here. So we'll just call it example 16. And I want to go ahead and do, let's say, negative, let's see, we'll make it nice and we'll do out of, we'll do out of tens. We'll go negative, we'll go 27 pi over 10. There we go. I was going to pick something that could be reduced, but I don't want to do that. All right, so this one is negative. So we're going to have to fix it and we're going to have to make it positive. So let's start by making our table. So again, 0 is on the right. Halfway around the circle gets me to pi. And since we're in tenths, I want to call 1 pi 10 tenths. And I want to call 2 pi, 10 and 10, would be 20 tenths. Okay, straight up above would be a half. So if I cut 10 in half, that would be 5 tenths. And then remember, if I add these two together, that would give me 15 pi over 10 down on the bottom. All right, so I'm going to go up here, and I'm going to take that negative 27 pi over 10. So we've got a problem. We got to add 2 pi because we want to make that positive. So if I add 20 pi over 10, that's still negative 7 pi over 10. So what do I have to do? I got to add 20 pi over 10 one more time, and that gives me 13 pi over 10. Okay, so I'm going to put this on my circle because it fits in between 0 and 20, right? Negative 7 doesn't fit in between 0 and 20, so I wanted to find a positive coterminal angle that would fit on my graph. All right, so if I start at 0, I go up to 5, I go over to 10, but I'm short of 15, right? So we need to be in quadrant 3, and 13 pi over 10 would be right there. Okay, so it would be in quadrant 3. Okay, let's find our reference angle. Okay, so our reference angle is how far is it to the closest x-axis? Well, the fractions are nice, right? It's 13 tenths to 10 tenths. So that's going to be 3 pi over 10. Oops, that's kind of messy there. So my reference angle is 3 pi over 10. Okay, and if I want to find a positive and a negative coterminal angle, I'm just going to start with that negative 27. And we actually did that over here, right? I started with negative 27. I added 20, which gave me a negative. So I actually can go ahead and use that negative 7 pi over 10 here because I added 2 pi to get a coterminal angle that happened to still be negative. And I added 20 again to get 13 pi over 10. So 13 pi over 10 is an example of a positive coterminal angle. Okay, for the negative coterminal angle, I also could have taken negative 27 pi over 10 and subtracted another 20 pi over 10. So I would have had negative 47 pi over 10. That would be another example of a negative coterminal angle. So you can either add 2 pi or subtract 2 pi. It all depends on when you add 2 pi, does that angle stay negative or does it go positive? Okay, if you have any questions, we will go over these tomorrow, but you can also ask Miss Golden for some help in class today. Thanks.